Yes, now let's see the example for the context-free grammars for the question on automata. Here, consider the NPDA with the transitions del of Q0, comma A, comma Z equal to Q0, comma A Z, and another transition as a del of Q0 AA equal to Q0, comma A. Del of q0 comma b comma a equal to q1 comma lambda, and del of q1 comma lambda comma z equal to q2 comma lambda. So kindly remember the two conditions to be satisfied that we have discussed in the previous video. That we have discussed as if we are going to define the grammar, by that time we have to satisfy the two conditions. That machine have to satisfy the two conditions. One is the final state must be reached only if the stack is empty, and another one is we have taken the transitions for which we have defined as a del of q0 comma a comma del of q0 comma a equal to c1 comma c2 up to cn, where ci equal to qj comma lambda or ci equal to qj comma bc. So it means either the stack content may be increased or decreased by one non-terminal. But while looking into these transitions, for example, for the first transition, here the top of the stack is Z, and when the machine is in the state Q0 and when it is reading the input symbol A, by that time this Z is the top. By that time we are just pushing the non-terminal A onto the stack. That means we are incrementing the content of the stack by 1. But while taking for this one, here also the top of the stack is A. While reading the input symbol B, A has been popped out from the stack as we are having the lambda here. It means here it is decremented, right? Next one, once if you are taking for this transition, here the top of the stack is Z and it is popped out. So here pushing operations performed, and here popping operations is performed. But while taking for this transition, del of q0 comma a, there is no other the operations performed here, either pushing or else popping out. You are not at all either incrementing the content of the stack or else decrementing the content of the stack. But as per the conditions that we have discussed, either we have to increase the content of the stack or else we have to decrement the content of the stack whenever your machine is moving from one state to another state, or else whenever your machine is reading the input symbol, there must be changes should be happened in the stack. So in order to change, in order to meet those two conditions, what I am just going to do it here is I am just going to rewrite these transition as del of q0 comma a comma z equal to q0 comma a is z. So we can write the first transition as it is. We have to change this transition alone. That's why we can write it as del of, we can introduce one new state as q3. So del of q3 comma lambda comma z equal to, here we can write q0 comma a is z. So here the top of the stack is z. We are just pushing the symbol A onto the stack. Next, in order to achieve this one, we can write a del of q0 comma a comma non-terminal a equal to, we can write it as q3 comma lambda. So here the A is the non-terminal A is popped out, right? So that's why it's satisfying those two conditions. Then we can write the transition as it is del of Q0 comma B comma A equal to Q1 comma lambda. Then del of Q1 comma lambda comma Z equal to, we can write it as Q2 comma lambda. So for these transitions only, we are going to define the grammar. So for defining the grammar, we have to make use of the things that we have discussed in the previous video. Here what we are going to do it here is, we have rewritten the transition like this one. Then with reference to the rules that we have discussed earlier, we are going to frame the context-free grammar. So at first we have to check for the transitions in which format the transition is available. Here del of Qi comma A, here also del of Q0 comma some input symbols are here and some non-terminals are here. But what we have to do it here is, we have to check whether it is in this form or else in this form here. While considering these things, at first we are going to take this one Ci equal to Qj comma lambda. So where we are having in such form means we are having this transition, this one. For all these three transitions, we are having Qj comma lambda only. So based on this rule, we can define the grammar. At first we can define for this transition. For example, del of Q0 comma A equal to Q3 comma lambda that we have taken here. I am writing here del of Q0 comma A equal to Q3 comma lambda. Here you can take Q0 as the Qi and Q3 as the Qj. So you can make use of this form to define the grammar. For this transition, you can define the grammar as Q0, and here they have written the non-terminal here, so you can write A here. And then they have defined Qj. So you can write Q3 here. It tends to the input symbol. So here the input symbol is A. So you can write it here. And next, what we are going to do it, the next one process is, we are going to define the grammar for this transition in the same way. So del of Q0 comma B comma A equal to Q1 comma lambda. So here Q0 is Qi, this is Qj. So you can define the grammar. Since we are having lambda here, we can define the grammar by this methodology. So you can write Q0 comma A comma Q1 tends to the input symbol B. In the same way, we can define the grammar for this transition also. So del of Q1 comma lambda comma Z equal to Q2 comma lambda. You can write it here. This one is the Qi and this is the Qj. So here, how can we write here is, we can write it as Q1 comma Z comma Q2 tends to the input symbol empty string lambda. So here we have defined the grammar for these three transitions using the form 1. Since we are having the form Qi comma lambda. But while looking into these two transition, it's not at all in the form of qj comma lambda. It's in the form of qj comma bc. So we have to define the grammar for these two transitions by using this methodology only. Next we are going to define the grammar for this transition. So what I am going to write it here is a del of q0 comma a comma z equal to q0 comma a z. Since it is in the form of ci equal to qj comma bc, we are going to define the context free grammar in this form. That's why here I have written as qi a qk tends to a qi b ql ql c qk. These things that we have seen earlier itself. With reference to this one, here I am defining qi is q0 and qj as qj as q0. Where qk and ql takes all the possibilities of the internal states. So at first we can define the grammar as q0. q0, you can write this z here, and then qk. Qk means we have already mentioned qk and ql takes all the values of the internal states. So at first we are going to write it for q0. So q0 tends to input symbol. What's the input symbol here? It's a. That's why we can write a here, and then we have to substitute a qi. Qi is q0, so q0, and then we have to push the symbol a here. So a, then we have to write it for ql. We are going to take all the possibilities of the internal states. So at first we are taking ql as q0. And then we have to write it as q0. Here C, it means we have to include Z here, and the qk value. Qk value here we have taken q0. So you can write q0 here. Then we have to write the grammar for the next one possibility, because the first state we have defined ql as q0. Then we have to define it for q1, q2 and q3. That's why here you can write it as a of q0, and then a q1, then q1 z q0. Then for the next one state q0, then we have to write a q2. Then we should write it as q2 z q0. Then we have to write q0 a q3, and then q3 z q0. So that's as the states here is q0, q1, q2, q3 we have written for all the possibilities for the ql. Next for the qk we have written it for q0 only. Then we have to write it for the q1, q2, q3 also. So here I am writing as q0 z q1 tends to we can write it as a q0, and then a q0. Here q0 we have to write z. Here we have to write the qk. Here the qk is q1. This is qi. So we are substituting here. So that's why we are getting q0 and then q1. Then we have to write it for all the possible values of ql. That's why a of q0, a q1, and here Q1 Z Q1. Then A Q0, A Q2, then Q2 Z Q1. Again A Q0, A Q3, Q3 Z Q1. That's all. Next, we have to write it for the Qk equal to Q2. That's why here Q0 Z Q2. It means Qi is Q0, Qk is Q2. So here also we can write as A of Q0, A Q0, and then Q0Z, here the Qk is Q2. So we have to write Q2. Then A Q0, A Q1, Q1 Z Q2. Then A Q0, A Q2, Q2, sorry, I'm sorry, here Q2, Q2 Z Q2. And then write A Q0, A Q3, Q3 Z Q2. So in a same way, we have to write for the another one possibility as Q0 Z Q3. Here the Qk is Q3. So we can write A Q0 uppercase non-terminal A Q0 Q0 Z Q3. Next here we can write A Q0 A Q1 Q1 Z Q3. Here we can write Q0 A Q2, then Q2 Z Q3. In the same way we can write it here Q0 A Q3, then Q3 Z Q3. That's all. For this transition, we have written for Q0, Q1, Q2, Q3, and for each thing. So this is a Qi, Z, Qk. No, here the K value ranges from 1 to 3, and the L value ranges from 0 to 3. I'm sorry, here the K value ranges from 0 to 3, and here the L value ranges from 0 to 3. Like this one, we have to write the transitions for, we have to define the grammars for this transition also. Yes, we have taken this transition and it is in the form of this one. BC, that's why Ci equal to Qj comma BC. This transition is in the form of this one. So we are going to define the grammar with a reference to the second format. So what I am going to first do it here is I am just going to set Qi equal to Q3, and this is the Qj value, right? So at first I am just going to write it here as since the K value takes all the possibilities of the internal state, I am going to write it here as Q3 Z Q0 tends to there is an empty input string, so no need to write it here as lambda. So directly we can write it as Q0. Actually we have to write it here as Q0 The inputs, the non-terminal here is uppercase A. You can write it here. And then QL takes all the possibilities. That's why here Q0, then Q0 Z, and here the QK is Q0. So we can write Q0 here. Next, for the next one, we can write a Q0 A Q1 and then Q1 Z Q0. Next, we can write Q0 A Q2, then Q2 Z Q0. Next, we have to write for the next one possibility of QL. So A Q3, then Q3 Z Q0. So after writing these things, then we have to go for the next one as a QK equal to Q1, such that Q3 Z Q1 tends to, we can write Q0. Here we have to write Q1. Wait a minute. Here we have to write Q0 because QJ is Q0. That's why here we have to write Q0. And then A. Then we have to write the QL value. It ranges from 0 to 3, and then Q0Z. Then we have to write the QK. QK here is Q1, so you can write it here. Next, we can write Q0 A Q1, Q1 Z Q1. Next one, Q0 A Q2, Q2 Z Q1. Next, Q0 A Q3, Q3 Z Q1. So after this, we can end since L have taken all the possibilities of Q0, Q1, Q2, Q3. Next we can take QK equal to Q2. So we can have Q3 Z Q2, such that we can write it as Q0 A Q0 Q0 Z Q here Q2. Next Q0 A Q1 Q1 Z Q2. Next Q0 A Q2 Q2 Z Q2. Then Q0 A Q3, then Q3 Q3 Z Q2. Then we have to write the grammar for the next one possibility of QK, that is Q3 Z Q3. So here we can write a Q0 A Q0, then Q0 Z Q3, and then Q0 A Q1 Q1 Z Q3. And we have to write Q0 A Q2 Z Q3. Then Q0 A Q3 Q3 Z Q3. So that's all. Now we have written the possibilities for this transition also. So after writing these things, what we have to do it here is we have to remove the repeated productions. We have to eliminate the repeated one. So that we will discuss it here. We have to eliminate the repeated one on the left recursion for the grammar that we have defined for this one as well as for this one. Yes, now we are going to remove the useless productions. How we are going to remove the useless productions means we have to check for the variable whether that variable which is present on the left hand side means then we can have it. Or else if a particular variable is not at all present on the left hand side of the productions means simply we can remove that one. For example, here we are having Q0 A Q3, Q0 A Q1, and there is no productions for Q0 A Q0, as well as we are not having any productions for Q0 A Q2. So what can we do it here is wherever if we are having Q0 A Q0 and Q0 A Q2, we can remove that one. For example, wherever we are having Q0 A Q0, here we are having, so simply we have to remove this one. And next Q0 Q0 A Q0 A Q0, here we are having, we can remove it. Here also we are having, we can remove it. Here also having, we can remove it. And then here also we are having, we can remove it. So wherever you are having, you can remove that one. Next we have to remove Q0 A Q2. So Q0 A2 means we have to remove this one. And Q0 A Q2 remove here, Q0 A Q2 remove here, and then remove here. Here also we are going to remove it. Yes, we have removed all these things. So next what we are going to write it here is simply we can conclude the grammar after removing the useless productions. It means these are all the productions here. But what's happening here is even though these productions are used or not, there is no impact in your push down automata. That's why we can remove this useless productions. It means even without these productions also your machine will work finely. That's why we are going to remove this useless productions. So after removing this useless productions, we are getting the productions as Q0A Q3 tends to A and Q0A Q1 tends to B. And then Q1Z Q2 tends to lambda. So in the same way we have written for all the productions. In each productions we have removed the useless productions and the resultant productions is this one only. So these are all the productions which are primarily main productions which are used for defining your non-deterministic push-down automata with the start variable Q0Z Q2. Q0 is the initial state, Q2 is the final state. So this is the thing. Once again I am saying they have given the transitions. based on the transitions, we are going to check whether it is satisfying the two conditions that we have seen earlier in the previous video. Once if it is satisfied, then we can apply those two conditions in your transitions and you can frame the productions. If not, if it is not at all satisfying those two conditions, means we have to rearrange the transitions in order to satisfy that conditions by introducing a new state. So after rearranging the transitions according to the two conditions, we can apply those two conditions and we can frame the productions. So after framing the productions, we have to eliminate the useless productions. After eliminating that useless productions, whatever the productions that you are getting, that will be considered as the main productions for defining your non-deterministic push-down automata. That's all. I hope that you have understand the concepts clearly. In case if you are having any doubt, kindly post your queries. Thank you.